Hey guys, I'm Matt, a developer from Ohio, and in this video I'll be walking you through the Page Visits Funnel project. To complete this project, you'll need to be familiar with data frames, aggregates, and merging. Let's get started. In this project, we'll use Pandas to build a funnel, which is a description of how many people drop off at any step of a multi-step process. In this case, we'll be taking a look at how many visitors add an item to their cart, how many click on checkout, and how many actually make a purchase. We'll also look at how long the average users spend on the site before making a purchase. We'll start by taking a look at our data frames so that we know what kinds of data we're working with. We'll print out the first few rows of each frame with the head function. So I'll print out visits.head, and I'll do the same for the other three. Now if we take a look, we'll see that visits lists all of the users who have visited the website, cart lists all of the users who have added a t-shirt to their cart, checkout lists all of the users who have started the checkout process, and purchase lists all the users who actually purchased a t-shirt. Now that we know what these data frames look like, we can remove the print statements. I'm just going to comment them out in case we need to reference them later. So I'll select all of these and add a triple quote wrapping, which comments them out. It's nice to keep our output over here looking clean. We'll merge visits and carts with a left merge. A merge will give us all the columns from both data frames. Left merging means that we'll exclude user IDs that only appear in cart. So we'll use pd.merge. We'll select visits first as the left data and cart as the right, and we'll use how to select a left merge. I'm going to save this merged frame as visits cart, and I'm also going to print it out on the next line so that we can reference it for the next few tasks. So I'm going to print visits cart. And if we save that, we can see it appear over here with visit time and cart time. To get the number of rows in the merged frame, we can use the len function for length. So we'll type len with visits cart as the parameter. Save this length as visits cart rows. So visits cart rows, so that we can print it out and use it later if we need to. So I'm going to go ahead and print out visits cart rows and hit save so that we can see the output of how many rows there are. And there are 2,052 rows. Looking at our merged visits and cart table, we see a lot of NAT in the cart time. This means not a time because there is no cart time data for these rows. We can count them by selecting null rows from the cart time column. So I'll select len with visits cart and the condition visits cart.cart time is null, which is going to return true for any row where the cart time is NAT. We'll save this number so that we can print it out and use it in the next task. So I'm going to save this as null cart times, and I'm going to go ahead and print that out. So I'm going to print null cart times, save, and we can see how many of those are null. So 1,652 of the total 2,052 rows have a null time. If there is no cart time for a given row, that user didn't add anything to the cart. Now that we have the total number of rows and the number of rows with no cart time, we can figure out exactly what percentage of users added items to the cart. Note that both of our lengths are integers, or whole numbers. If we do math with only integers, Python will try to return an integer, which isn't going to work for us. A number with a decimal component is called a floating point number, or float. If we convert one of our numbers to a float, we'll get a float back as a result. So I'm going to print out the null cart times, which I'm converting here to a float, divided by visits rows. So you only have to convert one of these numbers to a float. And null cart times over visits cart rows is going to be the percentage of our rows which have a null cart time. So if we save this, we can see the output. So this number, 0.8, is a float because it has a decimal component, and this represents 80.5%. So about 80% of our users visit the site but don't put anything in the cart. Let's repeat this process for the next phase. What percentage of users put an item in the cart but didn't proceed to checkout? The cart data frame only contains data for those who put an item in the cart, and the checkout data frame only contains data for those who proceeded to checkout. If we left merge these frames, we can check for null checkout times just like we did with cart times. So I'm going to save cart checkout as pd merge, cart as the left, checkout as the right, and we'll use how to define that it's a left merge. I'm going to comment out some of our earlier print statements and add a new one for this merged frame. So I'm going to comment all of these out, but I'm going to leave in this percentage because we're going to be referencing that in a little bit. Then I'm going to print cart checkout so that we can take a look at the data that we're using now. So if we take a look at this, we can see that it has cart times, which are all filled with a time, and we have checkout times, some of which are again NAT for not a time. And we're going to be checking how many of these rows have NAT in the checkout time. So we'll save the total number of rows and the number of rows with null checkout times so that we can compare them. So I'm going to save this as cart checkout rows. That's going to be the entire length, every row. And that'll just be len of cart checkout. Then I'm going to save null checkout times. That's going to be the length of from cart checkout, the condition that cart checkout dot checkout time is null. So this will give us the number of rows that have NAT in the checkout time column. To get our percentage of users who dropped out at this step, we'll divide the two values. Just like before, we'll need to use the float function in order to get a float instead of an integer. So I will print out the float version of null checkout times divided by cart checkout rows. And if we save that, we'll get our output, which is about 21%. Let's take a break from getting percentages and merge all of our data frames together into one data frame called all data and print it out using head. We'll need this merged data later. So we'll create the all data variable and select visits, and we're going to chain merge here. So we'll merge cart into visits using a left merge, and I'm going to copy and paste this for the others. So we'll merge in checkout, and we'll also merge in purchase. Then, after those, we can print all data head, and in our output, we'll get one table with all of the data combined: visit time, cart time, checkout time, and purchase time. We can see from all data that there's still one phase after checkout. To figure out how many users made it to checkout but didn't make a purchase, we'll repeat the process from our other two steps. So I'm going to do this above all data here, just below our other two percentages. And we're going to first merge. So checkout purchase is going to be pd.merge, checkout on the left, purchase on the right, and the how will be a left merge. Then we'll get the total rows, which will be checkout purchase rows equals the length of checkout purchase, and null purchase times is going to be the length of from checkout purchase, the condition that checkout purchase dot purchase time is null. So this is going to get us everything that is not a time in this column, but is a time in this column. Then we're going to print, we're going to convert to a float again, null purchase times, and we're going to divide that by checkout purchase rows. So what we're doing here is first merging, then getting the total number of rows, then getting the number of rows that have a null purchase time, and then we divide one into the other to get a percentage that are null. I've gone ahead and commented out all the print statements except the three relating to our percentages so that we can look at which step of the funnel has the highest percentage of users not completing it. So in our output down here, we have about 80% of users who don't add anything to their cart. We have 20% of users who add items to the cart but don't make it to checkout. And we have 16% of users who make it to checkout but don't end up purchasing. Back to our all data frame, we'll take a look at one more statistic. For those users who actually did make it all the way to a purchase, we'll figure out how much time they spent on the site. Codecademy has given us the code for a new time to purchase column in this task's instruction, so we'll just copy and paste that into our program. I'm going to paste that above this print statement so that the print statement will reflect this change. If you save, you can see that there is a new column in our all data all the way at the end, and this is time to purchase. So for anything with a purchase time, we get how long it took that user to purchase. Now that we're only looking at time to purchase, we don't need all those other columns. We'll print out just the series containing time to purchase. So we can copy this in from the instruction again, and I'm going to comment out this line here so that we're just looking at this series. If we save that, we can see that now we're just looking at a column of time to purchase. Finally, we can get the average time to purchase by using the mean function on this series. Once again, we've been given this snippet to paste, so we'll just add that in here, hit save, and we get an output that the mean time is about 44 minutes and 2 seconds. In this project, we used Pandas to build a funnel, which provided insight into which parts of a website needed to be improved. We used merges to look at specific combinations of data and stored information along the way. Merging is an important part of data analysis because it allows us to store our data in smaller, more manageable data frames without losing any of the functionality of storing it in one large data frame. I'm Matt from Codecademy. Happy coding!